Please go ahead.
Yes, thank you for introduction. Good afternoon, evening, everyone. So today I'd like to talk about overview of automated transport system we have developed and result of field application. Construction site requires the transport of many materials to the work site. This video shows workers transporting plasterboard on the trolley. The construction material weighs about 1,000 kilograms and it is dangerous and arduous labor. To solve this problem, we have developed an automated transport system. Automated trolley transport materials placed on the first floor of a construction site to an elevator. Then the, then, then the automated elevator moves the material to the upper floors, where, is, where it is transported by the automated trolley. This is an automated transport trolley. It has a loading capacity of 990 kilogram, body weight of 1,200 kilogram. It is equipped with 2D LiDAR for localized and stereo camera for detecting the position of materials. It can move straight, reverse, turn, and rotate by two drive and steering wheels. The fork scissors type and can take the load of material from the floor, eliminating the need for counterweights. This allows the total weight of trolley to be kept low, so it can be used on the upper floors. This trolley is mainly intended for use at construction site. It's an automated transport forklift. It has a loading capacity of 1,000 kilogram, body weight of 2,600 kilograms. It is equipped with 2D LiDAR for localization and the depth camera for detecting the position of materials. It can move in any direction, just like an automated trolley by 3 steering wheels and 1 driving wheel. This forklift is mainly intended for use at logistics and manufacturing sites. The operation manager has a tablet and enters operation instructions such as location of the material place and destination. The entered instruction converted into motion instruction for the robot by the management system. The management system sends instruction to the robots in movement categories such as moving, loading, and unloading. This is tablet screen. The screen displays a route map with defined material areas and elevator areas, standby areas, and so on. Areas are connected to each other by route consisting of edges and nodes. The automated trolley and forklift travel automatically using localization by 2D LiDAR. Usually, map data must be updated each time because of the environment at construction site changes such as a wall are added. However, the map uses drawing so that it does not need to be scanned repeatedly. Camera sensors are used for loading and unloading. Stereo cameras on automated trolley detect markers on skid pallet and measure the pallet's position. Since this pallet is intended for construction site, it is attached with a marker. The automated forklift uses a depth camera to measure the shape of the pallet and material, and can detect the position of pallet pocket and the top of the material. This allows material stacking and take out from upper. This video shows the automated transport at construction site. The manager is entering operation instruction on the tablet to transport materials on the first floor to the upper floors. Trolley loads the material. Materials placed on the elevator. The elevator automatically moves to the upper floor, and the trolley waiting on the upper floor takes out the materials. And then the trolley places it. This shows some transport composition. The previous video shows a case where both the trolley on the first floor and upper floors and the elevator are automated, as shown on the left. In this case, the composition of one manager and 4 automated trolleys. In addition, as shown on the center, there is a hybrid automation that combines manual. In this case, the transportation on the first floor and elevator are manual, and only the upper floors are automated. As shown on the right, manual operation requires a total of 5 people: a forklift operator, an elevator operator, a worker on the first floor, and 2 workers on the upper floor. The table shows productivity and cost. The manual operation is fastest, can transport 12 pallets per hour. On the other hand, the full automation can transport only 12 pallets per hour. The costs of each are reference only. The fully automated system has low productivity and high cost because of the cost for facilities in addition to the robot. The hybrid system has lower facilities cost and reasonably high work speed. This video shows a test run of the automated forklift at logistics. The automated forklift detects the position of material and pallet and transport them. When placing materials, the forklift detects the top edge of an already placed material and stack it. This is summary. Thank you for listening.